Hello everyone. In this video I am going to discuss further about circles. Number 1 is equation of a circle on given diameters. x1, y1 and x2, y2 are the two endpoints of the diameter. So what will be the equation? It is very easy by using this formula. X minus x1 into x minus x2 plus y minus y1 into y minus y2 is equals to 0. We have to put the values of x1, y1 and x2, y2 in this equation and we are getting the equation of the circle. Now number 2, equation of a circle touching coordinate axis. So number 1 is touching x-axis. Now the circle is touched meet x-axis at point h0. So using distance formula we can find the radius and our radius become k, because h minus h becomes 0 and only k left. So equation become x minus h whole square plus y minus k whole square is equals to k square. Now if the circle is touched with y axis, that means this side, suppose the center is hk and this point is 0k. Now k minus k becomes 0 and when we are using distance formula, radius become only h. So the formula become x minus h whole square plus y minus k square is equals to h square. If the circle is touched by both the axes, that means a circle, suppose circle is here, so this distance and this distance equal. Let's take it, I'm going to make different diagram. Suppose our center is at hk, this point h0, here 0k. When we are using distance formula, this distance become k and in between these 2 points the distance become h. So the radius must be equal, that means h is equals to k. Let it be alpha. So the equation of this circle become x minus alpha square plus y minus alpha square is equals to alpha square. Third point is length of tangent from a point to a circle. We have to calculate the length. Let's take a circle. Suppose from point P, x1, y1, a tangent is drawn to the circle at point A. This is our center O, some hk. A triangle is formed APO, where at point A it is 90 degree. So we have to calculate the length of PA. And the length of PA is using Pythagoras theorem. It is equals to square root OP square plus AO square. This is our radius. And the radius is, we all know that z square plus f square minus c according to the general formula. G and f minus g minus f is the center. So we can calculate this distance by using distance formula, and from this we can find the value of length. Radius, this distance can be found by using distance formula, and after putting the values we get PA. In actual, if the equation of the circle is given and the value of this point is given, then we can easily calculate by putting this this point on the equation, and that is S1, square root S1, where S1 is, suppose equation of the circle is x square plus y square plus 2gx plus 2fy plus c is equals to 0. So the length of tangent at point P become square root S1, that is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Directly put this point into the equation and square root, find the square root of that value, and we will find the length of the tangent. Next question is intersection of a line and a circle. Let's take a line as y is equal to mx plus c and a circle x square plus y square plus 2gx plus 2fy plus c is equals to 0. Now we can use this value into this equation. It become mx plus c whole square plus 2gx plus 2f mx plus c is equals to 0. After solving this value, it the required equation is in quadratic form. Square x square terms 2gx, here x and some constant is left in it. So after it is in form like example ax square plus bx plus c is equal to 0. Let it is in form of this equation, so we can calculate the discriminant here. Discriminant is b square minus 4ac. From this equation, when we are finding the value of discriminant, if discriminant is greater than 0, then our line cut the circle in two distinct points. If discriminant is equals to 0, then this line is tangent to the circle, is tangent to the given circle. If discriminant is less than 0, then line and circle do not intersect each other. Our next topic is equation of tangent to circle at point P on the circle. Now we have to calculate the equation of the tangent. Suppose the circle equation is x square plus y square. This is our circle. Suppose at point P some point is x1 y1. Tangent is drawn at point A. So we have to find the equation of this tangent. So its formula is, in place of x square we have to replace with x1. In every, if the term is in square, then we use as x1. If in y square we replace with y1, and in place of x we put x plus x1 by 2, and in place of y we use y plus y1 by 2. So the equation become y1 plus g x plus x1 plus f y plus y1 plus c is equal to 0. This is the required equation of tangent. Now equation of tangent to the circle having slope m. Very important topic. Let's take one circle. Suppose one tangent at point P, x1 y1. Suppose this is a circle with center minus g minus f. So we have to find the equation of this tangent. Only slope is given m. Its slope is m. So first of all, we know that this is our radius, and let the equation of tangent is y is equals to mx plus c, having slope m and c be the some constant. So if instead of minus g minus f I am taking simple circle having center at 0 0, let's take x square plus y square is equals to a square. For understanding, I am using this circle with the center at 0 0. So now we can calculate the radius with respect to this line by using distance formula, and it become in mx minus y plus c is equals to 0. 0 0, the distance from this line, how can we calculate? By putting the values 0m minus 0 plus c mod divided by square root coefficient of x square m square plus 1. which is equals to radius, and in this equation, according to this equation, radius is a, so we get the value of a from here, and it is plus minus m, no, not m, plus minus c divided by root 1 plus m square. So now we can, now in place of a, in place of this c, I am putting the value, and it become y is equals to mx plus minus a square root 1 plus m square. In this is the required equation of tangent. If center minus g minus f is given, now suppose in place of 0 0 center minus g minus f is given, so the required equation become, now the radius a will be equals to square root g square plus f square minus c. This is the formula for radius. So the equation become y minus k is equals to m x minus h plus minus square root g square plus f square minus c into 1 plus m square. This is the required equation. Now the next topic is director circle and its equation. Director circle. Director circle, I suppose this is a circle. I am going to draw two tangents meet at point P. The locus of this point is called a director circle. Wherever I am making two tangents, it will meet a director circle, and the equation for this director circle is x minus h square plus y minus k square is equals to square root 2 times radius, that is 2a square. This is the required equation for director circle. Next topic is equation of normal to the circle. It is very easy. Normal always, suppose let's take some tangent at point A, and this is our center O. Now normal is always perpendicular to the tangent, and it passes from the center. Suppose the center is HK. Now we can easily suppose slope of this equation is m. Now we know that the slope of this is minus 1 by m, because two lines are perpendicular, then their slopes are also reciprocal. Let's take this slope as minus 1 by m, and its slope become m. So what is the equation for this? A line passing from a single point and having slope m, we can easily find the equation of this line. It is y minus k is equals to m times x minus h. This is the required equation. But here I am taking hk. If we are taking h center as minus g minus f, so in place of h we put minus g, and in place of k we put f. So the equation of this normal become y plus f is equals to m times x plus z. This is the required equation. Because all the circles are given as x square plus y square plus 2gx, this is the general equation, and from this I am taking center as minus g minus f, and according to this center, this is our equation of normal. Next is equation of chord of contact. Suppose this is our circle. From point P I am going to draw two tangents. One more thing, here equation of tangent to the circle at point P is this. But what if I want to know the equation of two tangents? Let's draw one more tangent, then its equation become t square is equal to ss1. Here this is the value of t, this is the value of t, and s is this is our s, and s1 is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So after putting this value, we will get the equation of two tangents, pair of tangents to the circle. Next is equation of chord of contact. Suppose at point P some x1 y1, I am going to draw two tangents and this is the chord of contact. So now equation of chord of contact, this equation, its equation is T is equals to S1. What is the T? Let's equation of circle is and the value of T become x1 plus y1 plus gx plus x1 plus fy plus y1 plus c is equals to 0, and the value of s1 is x1 square plus y1 square plus 2gx1 2fy1 plus c is equal to 0. Whenever we are comparing this value, we will get the equation of chord of contact. Next is orthogonal intersection of two circles. Let two circles orthogonally intersect each other. Let's its tangent is this. Suppose this is the radius r1, this is the radius r2. Draw two tangents. It is perpendicular, having center c1 and c2. Then its equation is r1 square plus r2 square is equals to d square. Orthogonal intersection of two circles, the condition है r1 square plus r2 square must be equals to d square. D is the distance between c1 c2. Here d is c1 c2 distance of c1 and c2. So in place of, if the equation of first circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0, and this circle is equation is x square plus y square plus 2g1x plus 2f1y plus c is equal to 0, then our new condition will form, that is 2g1 plus 2f1 is equals to c1 plus c2. After solving this using this finding distance r1 and r2 and d, we will get this result. Instead of solving all this equation, we can simply learn this value. Next, different cases of two circles. Suppose two circles are far away from each other, then number of tangents can be drawn is common tangents 1 2 3 and 4. Here the distance between, suppose this is our center c1 and this is our center c2, having radius r1 and r2. Here the distance between two centers is greater than r1 plus r2, then the number of tangents can be drawn is 4. The number 2, circles touch each other externally, then common tangents 1 2 and 3. Number of tangents is 3. Here the center c1 c2 is equals to r1 plus r2. The third condition is, when circles intersect each other, then number of tangents are 2. Number of tangents is 2. Here the difference between r1 and r2 is less than c1 c2, which is less than r1 plus r2. And the fourth condition is, suppose this is our circle 1 having center c1, this is our radius, the second circle is lie on this radius. Suppose this is our c2. Here c1 c2, the difference, when we are subtracting only this much portion left radius, So C1 C2 is equals to R1 minus R2. The number of common tangents is 1. The another condition is when the circle lie inside small circle. Here C1 C2 difference is less than R1 minus R2. So it lie inside. There is no common tangent. No common tangent. Our next topic is pole and polar of a circle. Pole and polar of a circle.